blog about it? How do you know?
We were talking about it because one of our buddies was from the workshop. Yes. And then the other one's like, okay, good, I'm not going to do shit, but I had stuff in rigid.
Yeah, the only stop where we're going back to the comments.
But he got from you too. So
That's not too much. I got one of the liberals on eBay. I got a $50 original. It's on, I got a 450 bid on it, so I just relisted the bid. It fucking removed it. It says you can't sell guns over 25 caliber.
you put air so
No, I put air rifle. So, okay, just think you call there. I put on 150 $3,000 PSI and yeah, I just gotta print up again. And I said liberals that you keep trying to get this.
You guys enjoy the day off?
Yeah. Pretty much did the same thing I do in here, nothing.
Well, that works. I guess. You're paying to be here.
I know.
I mean, he's getting paid either way, whether you're doing something or not.
Right, exactly. And if you just keep retaking my class, I probably get paid more, right?
Yep.
That's how it works out.
So perfect.
We're going to talk about logic today. We're going to look at Booleans, ifs, right, if-elses, loops, and then we're going to get into string operations and character operations, all of which will help you on your first coding assignment, which I'll introduce today as well. So that's kind of what we have set up for today. You don't have questions before we get going? Good. All right. So the two ampersands, right? What do we call that? Logic operation. And, right? And and's all about both things have to be true in order for the whole thing to be true, right? So line 10, right? It's outputting true and true, and we're thinking that the operation on the right, true and true, should be what?
True.
True. The next operation, true and false, should be false, because as long as one side is false, then the whole and operation is false, right? False and true, false, it doesn't matter the order, and then false and false obviously is false. Want to go with that? Right? This is about building Boolean expressions and taking multiple Boolean expressions and bringing them together. Obviously, in your code, you're not going to say true or true, right? But you're going to have some comparison on one side, right? X is greater than 5, or, right, X is less than 3. Right? Something that will evaluate to true or false. Right? So the two pipes are called what? Or, right? So on one side or the other has to be true in order for the whole thing to be true. Right? So true or true is? True. True or false is? True, yeah. False or true? True. False or false? False. That's the only time where the or operation is false is when both sides are false. And the exclamation point, right, is a what? What's this guy mean? Not, right? And not just what? Opposite. Yeah, right. So not true is false, right? And not false is true. Great way in code if you have some state that's either on or off, right? You just nod it and then just flip it over to the other side. Right? Have you found the key in the game, right? True or false, and you just flip it back and forth. In C++, if you output Booleans, what do you normally get? Those that know C++, what do you normally get?
1 or 0.
1 or 0, right? 1 for
True.
and 0 for false. Good, right? What I've done is I've added this other thing called bool alpha in my output, and that will actually output the words. So I'll actually get true or false, just for readability's sake. So I'm gonna build this, right? So I'm gonna say g++ class.cpp, and I'm gonna run it, right? And this is just our truth tables telling us that what true and true is true, true and false is false. This is just checking what you told me, and you guys did it all correctly. So we're all happy there, right? True or true is true. Now, if I took that bool alpha, I'm gonna take it out just for a second. If I take that bool alpha out, right, and I do it again, right, you'll notice that it's still working. Huh. Maybe I'll include it in there once. Let's see. Or operations, true or true. That's probably true. I think once you set up the bit once, let's try the top one. Yeah, everyone see that? True and true, right? Output it as 1. Right? Usually when you output Booleans, you do 1. For you, you don't need to use the bool alpha. I was just doing that so we could see it, right? But for us, 1 means true, 0 means false. And in reality, in C++, anything that's not 0 means true, and 0 means false. Does that make sense? So there's infinite possibilities of what could be true. There's only one thing that could be false, right? And that's when, right, it's 0. In C++, you'll get used to the fact that we type convert quite a bit, right? Booleans are really Booleans, but all of a sudden they get converted to 1s and 0s, which are really what type? Integers, right? And that happens a lot implicitly for us. Questions on those?
Nope.
No? Should we do some if statements? If statements are the thing that pretty much look the same in every language, right? If, and then for us we need parens. In Go you don't need the parens, but in C++ you have to put the parens in order to get it to go, right? So if something, right, what goes in the parens? Right, say again, the condition, right? So I'm going to do BE for Boolean expression, right? So something, some expression that becomes a value, right? Remember expressions become a value. A Boolean expression becomes a value, and the value that it becomes is what? It's Boolean, then it should be 0, 1, true or false, right? So Boolean expressions always evaluate to true or false, and if statements, right, act on that Boolean expression. If it's true, then we run the code inside of the curly braces, and if it's false, what do we do?
Skip it.
Right, just skip ahead, right? So some kind of branch, right? So we're coming along in our code, we hit an if, right, and we go one way. In this case, there isn't another way. We either go that way and then we come back, right, or we go straight through. Depending on if the condition is true or if the condition is false. Right? We can add the else. Right? You'll notice I have the curly braces on there as well. If the Boolean expression is true, we run the code inside of the if. Right? Otherwise, the Boolean expression is false, and we run the code inside of the else. We should be pretty good with this. I hope we're not putting you to sleep. But right, the if goes one way, right, or the what? Right? If it's true, we go this way, and it's false, we go that way. Right? And then probably, right, we're going to come back together and continue on what we need to do. What else can you add? Else if, right? So I can do if, else if, else, right? And I can do as many else ifs as I want, right? This says if this Boolean expression is true, run that. Else if, and what should you always have after an if?
Parentheses.
Always have parentheses, right? So after any if that you see, you always need parentheses in some Boolean expression, right? If the Boolean expression is true, run the first thing in the if, right? If it's not true, go to the else if, the first else if, right? And see if that's true. If it's true, run the code. If it's not true, there's an else, right? It's going to run that else, right? Call this multi-way branching, right? Go this way, or that way, or that way, or that way, right? As many as you want to go. Since, right, it's all about this semester, it's all about taking what we knew before, right, and figuring out how to be better and how it all works. Really, an else if statement is really an else statement that has an if else statement inside of it. So I'm going to actually tab it over like this. Right, that's actually technically what it looks like, and if I had another one, right, I would actually have another Boolean expression in here. Everyone see how the indentation sucks? That's technically what it's doing. Saying, right, if your Boolean expression is true, run this code. Otherwise, you go to an else, right? Technically there is no else if statement in C++, right? You just go to the else. Well, what is the else? The else contains another what? If statement. And so I go in there. If it's true, I run it. If it's not true, I go to the else. Right? And if I go to the else, then what's inside of that else? Another what? If else statement. Does that make sense? Right? But we switch them together because this is really hard to read and actually a lot harder to write. But technically, that's what's happening. Why do we care? How do I get to this else? You have to have a lot of falses, right? So the first if has to be false, the second if has to be false, the third if has to be false, the fourth if has to be false, right? So on and so forth. So your first if condition should be what? All right, if you want to write better code, your first if condition should be what? You think about it for a minute, marinate on it. We just said to get to the last else, everything else has to be what? False. So when everything's false, that's where we have to do check after check after check after check, right? So your first if statement should be the thing that happens the most, right? The thing that most commonly is true, right? Does that make sense? Mm-hmm. Right? Instead of knocking on 20 doors until you get to the right door, put the right door, the door that most people go to first, right? And then put the next door second, the next door, right? Put the if that happens the most at the top, so you don't have to check, right, everything else to get where you need to go. It is the first things, which makes your code the most efficient. If 90% of the time x is greater than 5, right, that's your if x is greater than 5. Don't go x is less than 5, or less than or equal to 5, and put that condition right way down below. Does that make sense a little bit? Right? It's all about writing more efficient code for us. All right. Last class we talked about constants, right? Constants was a way for us to name, right, numbers. Right? Constants are a way for us to name numbers. They don't have to be numbers, right? Literal, so they could be numbers. They could be true or false, although we already have things for that. They could be characters. They could be strings, right? But some way of naming some value, right? If we have a lot of values to name, we can do something called enumeration, right? So we can say enum, right? We give our enum some name. In this case, I'm going to say grades, right? And then I'm going to do curly braces. And inside the curly braces, I'm basically going to define a list of constants, right? Is the way that we're going to use enumeration. So we're going to define this list of constants for grades, right? And inside of that, I can do things like grade A, right, is 9, comma, grade B is 8, right? Grade C is 7. Right? I'm going to explain why I'm doing 9, 8, and 7 for my grades. Grade D, right, is 6. And basically, I've created 1, 2, 3, 4 constant variables, right? 4 constants. Where grade A really is the value 9, grade B is the value 8, right? Grade C is the value 7, and grade D is the value 6. Right? We're naming our numbers, right? Because later on, it's going to make our code more readable, right? Because I won't see a 9, I'll see things like grade A, right? And then the other thing is that they won't change, right? Remember, constants don't change, right? And I'm going to do this because you're going to use it with a switch statement, right? And so I'm going to create, right, a variable for my grade, and grade, cout into your grade. I don't want a new line. All right, I'm going to bring that grade in. All right, remember, to get stuff in, cm, two greater than symbols, and then write the value, or the variable that we want to hold that value in. So our program creates one storage, tells them to enter their grade, we get their grade, right? And now I want to make a decision based on the grade, right? The user can enter anything, so I need to write some kind of decision to say, well, if their grade is, an A, then tell them it's an A, right? If their grade is a B. And we can write an if-else-if statement to do that, but another way of doing it for this multi-way branching is writing a switch statement. All right, and so let's look at a switch statement. I'm going to switch. Right, switches always switch on what's called a controlling expression. Okay, controlling expression is different from a Boolean expression, right? Boolean expression always evaluates to what? True or false, right? A controlling expression evaluates to a value. Okay, and the cases in my switch, right, will correspond to the quality for that value. So that value can, right, become any value, but it has to be integer based, which means that it only works for integers, it works for Booleans, and it works for characters. Okay? Switches in C++ do not work with floating point values, and they do not work with strings. So that's a limiting factor in them. But they are more efficient than if else if statements. They will go directly to the code, right? So it's not going to do 50 checks to get to the 51st decision. It will actually take you right where you need to go. All right. So let's look at this switch. I'm going to have a case. All right. I'm going to say case grade A. Right. I'm going to see out. Right. You got an A. Right. Cases always end with breaks. Right? If you don't put a break in a case on a switch, it will run the code in the next case. Which sometimes you want to stack cases, but most of the time you don't. Distinct, right? I always think of it as the colon is your opening curly brace and the break is your closing curly brace. That's how I think of it. The colon is the opening, the break is the closing. So there's grade A, right? And then we can do case grade B. Let's see how you got a B. This time you only get 2 exclamation points, not. But now the question is, right, if we look at our numeration, we say grade A was 9, right? But when asked for their grade, it's probably going to be something like what? 95, 92, 83, hopefully not 51, right? So cases are all about this value, which is 9, equaling that controlling expression, okay? So how do I take values like 92, which is an A, and 99, that's an A, how do I make them 9? What? Well, we can't do floating points with switches. So I take my grade, and I divide it by 10. Right? Remember, if grade is an integer, and 10 is an integer literal, an int divided by an int is a int. Okay? And so 99 divided by 10 is 9. Because 10 goes into 99 9 times. There's leftover, but we don't care about the leftovers. You always just throw the leftovers away, right? Right? 91 divided by 10 is also what? 9. Does that make sense? To extract the tens digit, we just divide by 10. Right? Remember grade school math? We had the ones digit and the tens digit and the hundreds digit. So with integer division, we can divide by 10, 100, right? 1,000 to extract that digit out of a number.
What if you type 100?
If I did 100, I'd get 0, right?
Yeah.
Anybody did that?
No, I'm saying if you typed 100 as the grade,
well,
it'll come out as 10.
In this case, right, and we're going to fix it. In this case, right, it wouldn't be either of these cases.
Mm-hmm.
And because I don't have any like catch-all, nothing would happen. So you want to go down that path currently.
Couldn't you just say grade A equals 9 or 10?
Well, you can't do that with enumeration, right? So you can't set up logic. It would be nice, right? But you can't set up logic in your enumeration. You're just saying grade A is 9. So how do I catch that? Well, you do things like stack cases. Remember I said if you don't put a break, it will just go to the next case, which allows you to stack cases. You could do case 10. Right. So case 10 or case grade A. Right? What's the limitation on switches? You can't do ranges, right? If x is greater than 10 and x is less than, right, 100. Right? If you want to do a range of values, really switches are not the way to go. Defaults would be better for error catching, right? And we're going to get to a default, right? So the default down below for us is going to be, all right, see how you fail. Right? The default, right, is my else, right? So in this case, this class is kind of mean, right? You either get an A or you get a B or you what? You fail. If you guys have that mentality in this class, you'll probably all pass. Because even if you get a C, you're still going to pass. But if you have the mentality that anything less than a B is failure, then maybe that would be. I always talk about, I feel like there's 2 types of students, and you'll know which type of student you are. There's the type of student, well, there's 3 really. There's just ones that are good. They just either work all semester long, make it a great grade, right? The other 2 types of students are the student that works really hard at the beginning of the semester, and then hopes right? They kind of stop working at some point in the semester and hope that at the end their grade was just high enough to pass the class, right? Maybe you're that student, maybe you're not. You don't have to raise hands. We're not going to take a survey, right? There's also the type of student that, what? They don't do any work at the beginning of the semester, and at some point they're like, oh shit, I need to like do work in the class. And then they hope that by the end of the semester they've taken that 0 and got it just high enough to pass the class, right? Don't be either of those students. Be the student that just does your work and gets a good grade, right? As opposed to like crunching all the numbers the last week of class. Well, if I get 98.2% on the final test, my grade will be a 69.5, and I know if it rounds up to 0.5, and I'll pass the class, right? Don't be that student. Right? Just get your work in on time and do your work, and you'll be fine. Right?
So where you have case 10, grade A,
Yeah.
you only need one break.
Yeah, so what happens is every case label will run the thing after the colon. If there's no break, it will just continue. So it will in case 10, right, if that's what it matched, and then it will just continue on. So it will go into case grading.
So you don't just need one break.
Yep. If I had a break here, then that would be a problem.
Because then it would never run.
Right, that would never run. Well, it would run, but nothing would, it wouldn't, right? You wouldn't see it.
Isn't there a way to ask for like a range of numbers? Like if somebody just wanted to break it and typed like 20,000, you could just say case 10 through some big
No,
number.
not in C++. You can't do ranges,
Okay.
right? Switches are all about equality, right? Does the label for your case, right? Does that match what your control expression becomes? It's all about equal. What's the benefit? Efficiency, right? They will go to the case that you need to go to without checking through everything. And at compile time, it sets up all the efficiency for you. So it's not going to be like, oh, it's not a 10, go to grade A. Oh, it's not grade A, go to grade B. Oh, it's not grade B, go to the next thing. Right? That's how if-else's work. Switches go directly to where you need to go. Pretty cool? Should we see if I typed it correctly? No. Enter your grade. What grade did you guys get?
93.
93. Perfect. You got a 93, and you got an A. All right. I didn't do any inline, so it looks pretty crappy. All right. Enter your grade, right? In this passage, you get 79. What does it say? You failed. And honestly, I should have set up more cases for all that stuff. Questions there? We doing good? All right, so ifs, right, really if-else's, switches are all about branching, right? We also have something for repeating stuff. What is that? How do we repeat stuff? Okay, for loops, right? And really loops in general, right? So this is where there's a little distinction between Go and C++. Go just has a for loop. Everything that you do in Go, it's all based on a for loop. You can make that for loop run for forever if that's what you want. C++ has 3 loops for you. They have a while loop, a do while loop, and a for loop. Okay? So you're coming from Go and you're like, I love for loops, just keep writing for loops. They'll work the same. But the while and do whiles, they basically do the same thing, just logically or structurally, they're just set up a little bit different. So a while loop says while some condition is true, right, run the code. Right? So while, right, is true, and there's no really is true.
Can you just do while true?
So if you want your loop to run forever, then you could say while true, right? The literal value true, right? And your loop will never end.
It also take up too much memory, right?
It'll keep, right? Take up that CPU power. People write for what we call forever loops, right? They want it to run for forever, and if you want whatever it is to end, you can write break. Just like we saw breaks with switches, breaks will break you out of the loop as well. Okay? We don't have it too often, but like if you're writing a game or something like that, you'll have a game loop, basically a forever loop, right? While the game's not over. Right? So a lot of times people write that as while true, and then if you die, they'll just break you out of that. I think breaks are kind of lazy, right? You should be able to write the Boolean expression that while the game is not over, whatever that might be, right? Else, right? Well, I don't know what else I could run there. So those two.
Stealth.
Self. Right? All that stuff. So while true. So what has to happen in the while loop? Right, we're going to do something. Right, whatever that something is. Right, and what's the other thing I need to do? If I don't want the loop to run forever, what's going to have to happen? Well, not a return, not a break. I said breaks are lazy, and we're not lazy. Some terminating statement, meaning that something that eventually, not necessarily right now, but eventually is going to make this is true be what?
False.
False. Okay? Right? It could be something as easy as, right, is true equals false. Right? Or for us lazy people, right, I just said don't be lazy, and I'm going to say it, right? You can do that. Right? Both of those things do the exact same thing, right? I mean, this for sure makes it false. This just switches it. So if it was true, it's now what? False. And if it was false, it's now true. Of course, this loop's kind of lame because it's going to loop how many times? Once. And then it'll make it false, right? So how does it work? It checks the condition, right? If that condition is true, it goes in the loop, right? Stuff happens, loop ends, it goes back to the top, right? That's called an iteration. It checks it again. If it's true, we go run the code again. If it's false, we what? We break out of the loop. Right? So you get things like this, like right? X equals 5, right? And then while x is right greater than 0. Right? And the do something could be as simple as outputting x. We'll deal with the space for fun. And then, right, a lot of times in loops, you're going to x minus minus, you're going to x plus plus. Right, you could do like x minus equals 5. Or minus equals 2. Right? So now you're not going down by 1, you're going down by 2, right? 5 becomes 3, it becomes 1. And then eventually becomes negative 1, which is not greater than 0. But we'll just do x minus minus. Right. And you'll see that my output is what? 5, 4, 3, 2, 1, right? X is 5 greater than 0? Yeah, so we do something, and that something is output x, which is 5. 5 becomes 4. Go back to the check, is 4 greater than 0? Yes, rinse, repeat. 3, 2, 1, right? Remember, that condition has to become false. So x has to get down to what? 0, right? Did I output 0? No, but did it become 0? Yes. 1 became 0, goes back to the check. Is 0 greater than 0?
No.
False. Right? And then you have to jump over the body of the loop, just like an if statement, right? If an if statement's false, you jump over the body of the if. Right? Jump over it and then continue. One big thing about a while statement, if x started out at 0, what's going to happen? Well, yeah, right? The while loop will never run because it's 0 greater than 0. No. Okay? So what we also have is this thing called the do while. And the do while basically takes the condition and puts it on the bottom. Right, so I'm going to take that out. I'm going to put a do in there. Right? I'm going to while. And it's one of the only times where you get a semicolon after parens. But the do while does have a semicolon hiding at the end of the while condition. Okay. In this case, x is still 0, but you'll notice that there is no conditional check first. Okay? Because there's no conditional check, right, we go straight into the loop, so we see out what? 0, and then 0 becomes negative 1. Is negative 1 greater than 0? No. So do we continue to loop? No, right? So a while loop, right, is not guaranteed to ever run. A do while loop is guaranteed to run at least what? Once. Okay. Where are some great places to use do whiles? Things like user input checking, right? Do, get the input. While the input is wrong, do, right, get the input again. That make sense? So we need something first to check. So if you're going to take input in, and that input is going to be part of your check, then use a do while, right? If you already have what you're checking before, then use a what? A while. If you don't like whiles or do whiles, then use a what? For loop. For loops are great if you know how many times you want to loop. Right? Once again, we call those iterations. So if you know how many times you want to iterate, then a for loop is your friend. Okay? We use them a lot with arrays. We use them a lot with strings. Right? We'll see those for loops that work with that. But if I want to count to 100, right, then a for loop is where it's at. Right? The for loop has a lot of the stuff inside of it as opposed to on their own line. So int I equals 0, I less than or equal to 100, I plus plus, and let's start at 1 because I said I wanted to count. We'll count from 1 to 100, right? And we'll see out I and a new I. Right? What does I stand for? What? Iterator, right? Yeah, because each iteration, right, is a loop of the loop. Right? So I is the iterator. So I starts at 1, right? This is an initialization section. It happens one time. So I is 1, right? That's the beginning of the for loop. It never goes back to that, so don't think that's going to reinitialize I to 1. It's one time. Then it moves to the check, right? So we initialize, then we do the check. Is 1 less than or equal to 100? Yes. So we go into the body of the loop. So we output I was what? 1. At the end of a for loop, we go back to the update action. So I becomes 2. And then we go back to the check. 2 less than 100. Yes. Output 2. 2 becomes 3. 3 less than or equal to 100. Yes. All right, so on and so forth. Run that. This should look real nice, right? We get 100 all the way up to 1. It's an increment loop, right? I'm incrementing. That could be decrement, right? We could count down from 100 to 1. All right. You can also do things like I equals I plus 1, right? Or I equals I plus 2, or I equals I times something. Right? So your update action could be anything, but once again, your update action needs to eventually make this Boolean expression be what? False, right? So the update action makes sure that the Boolean expression is false, right? It is okay to output I, but usually it's not a really good idea to like do math with I in here, right? All right, so if I say I equals I times 5, and there, and I run it, you'll notice that my loop does 5, 30, 155, and then it's what? It's over. I is my counter, right? I set up my loop to loop 100 times. If I mess with I, right, inside the body of the for loop, am I going to loop 100 times? No, right? I'm going to loop until I is what? Not less than or equal to 100. So I is greater than 100. Do we know the inverses? Like I less than or equal to 100, right? The opposite of that is what? I is greater than 100. So when you not a less than or equal, right? If you want the opposite of it, it becomes a what? A greater than. In the same way, if I say I, right, is greater than 100, the opposite of that would be what? I is less than or equal to 100, right? Which is what we just had. If you have less than, right? If I is less than 100, then the opposite is what? Greater than or equal. Sometimes when we do the opposites, we forget that we need to put the equals in. Right? The opposite of I less than 100 is I greater than or equal to 100. Right? And so you need to write them in a way that you're catching, right, everything that you want. Questions with for loops? For loops in general? Whiles, do whiles, fors? I kind of went through it quick because I'm assuming that this is kind of review for us. Right? If you have questions about them, then come ask me. Right? You're also going to do write loops in your thing today. Your lab. I think you're going to do Goldilocks today. No one started it.
I looked at it.
Goldilocks and all sorts of fun stuff. Good? All right. So we're going to do some things with strings and with characters. Okay. in your assignment, your first coding assignment, you're gonna have to do things with strings and characters, so this is kind of important, right? I'm gonna include string, right? Really, you don't need to include string because string comes in when you include IOString. But I think it's good to just, right, say I'm using this, so there it is. And then strings have a using statement, std string, right? You don't have to do that, but if you don't, then you'll have to do std : string every single time. So I think it's nice to just do that and not worry about it. So strings are not a native type of C++. And what I mean by that is like ints, doubles, chars, booleans, right? Those are all built into C++. We call them plain old data types. Okay? Strings are an add-on to C++. Okay? They are a class, and we'll get to classes, that allow us to do some cool things with them. And they're also made in a way to make them feel like they're a native data type. So if I do string s, right, I do things like s equals hello. Right? This is assignment, right? Putting hello, right, the string literal into a variable called s. Okay? That works. No problem there with what we're doing. Right? You can also do things like concatenation, where you say s plus equals space world, right? Which is the same thing as saying s equals s plus world. Right? Plus with strings is really concatenation, meaning we're joining strings together, right? Just a fancy word for concatenation. Someone was sitting late at night somewhere and was like, you know, I want to make this sound super cool, so we're going to call it concatenation. And there it is. Right? So really, what's the value of s now? Hello world. Good, right? So the value is hello world. So if I was to see out s, right, that is what I should get. Except, right, stupid semicolons. Line 17, what? Put the semicolon before return. No, it's right there. Apparently, autosave doesn't always work. There we go. Hello, right? The joining of my two strings here. Is there music going on? Whose music is that? Maybe it's outside. Like I hear something going on. I'm like, I know washing machine. Right?
It's a washing machine?
I don't know what they're doing out there. You can do comparison with strings, right? Is this string greater than that string, or is this string that's smaller than that string? Okay? We don't do that often because it's not alphabetical order, it's lexicographic ordering, meaning that there's an order to lowercase letters being smaller than uppercase letters, or vice versa. So if you want to compare strings, you have to make sure you get them into the same case, right? Either all uppercase or all lowercase, if you want to compare. If I said int x, what's the value of x? Garbage, okay? But when I say string s, what's the value of s? The empty string, okay? S, right? Strings are not a built-in type, so they don't start with garbage, they start with some default value. And the default value for strings is the empty string, right? Denoted, right, really as, right, double quotes, and then closing double quotes, right? No value. Okay, strings can be 0 to many characters, okay? Strings always start as the empty string meaning 0 characters, right? But you can add characters to them, obviously I did it on line 10. But they do not start with garbage, they start with what's called the empty string. And you can do tests for that. You can say if s equals, right, that the double quotes, right, then you're good to go. Questions so far on strings? Those are kind of the basic operations. One cool operation that you can do is you can say .at on a string, right? And then inside of the parens, you give it an index or a number of where you want to get a character in that string. All right, so right now, I have a string called hello world. Let's get it on the board here. So I have hello world. Right? And each of those characters is at a location in the string. Right? H is going to be at location what? 0, right? Because computers always count from 0. Why? Because we're cool. We want to be different. Right? What do computers talk in?
Binary.
Binary, right? And so when everything's off on a computer, all the bits are what?
0.
0. And if all the bits are 0, then that value is 0. So computers always start counting at 0 because that's when all the bits are off. That make sense? Maybe that helps, maybe it doesn't. You know, like my brain still starts counting at 1, right? All right, 1, 2, 3, 4. The space is a character to 5, 6, 7, 8, 9, 10, 11. Right? I think I did that right. I have 11 characters in my string hello world, exclamation point. Right? And so dot out, I can put any number starting at 0 and going up to what? 11. So I can do this. Right? And you notice that what I get back is what? An exclamation point. Okay? Dot at the function, right? What it returns is a character. So S is a string. Dot at returns you a character. It returns the character at location, in this case what? 11. Right? So it returns the character, which is useful. Right? You can also, right, use square brackets, right? Treat it as if it was an array. Let's get rid of the dot. Right? You can do S11, right? And that'll do the same thing. Right, type. There we go. Right, it'll do the same thing. It'll give me an exclamation point. The problem, though, is that I only have characters from 0 to 11. So if I want a character 100, right, that might be a problem. Right, because there's no character 100 in my string. In this case, it seems as if I got no output. Right? I get some garbage value somewhere in memory, and that's how it's interpreted. Right? The safe way of doing things is to say, right, s dot at, right, 100. Because that's an error. What kind of error is that in my code? What? Logic error. Good, right? So some kind of logic error, which can actually turn into a runtime error as well. Right? Notice this time when I run it, right, I get an error. What happened? Basic string at, that's my function, right? And up here, the error was std what? Out of range, right? Because 100 is out of range, right, of the permissible values that dot at can take for the string. You can only take a value from 0 to what? To 11, right? And only take a value from 0 to 11. So if you go too far, you always get an error message, okay? Hopefully you realize this by now. Getting an error message every time when there's an error is a lot better than getting an error sometimes, right? Because if you did square brackets, you might get an error sometimes. Your program might crash sometimes, right? And so we want to write code that will crash every time if I did it wrong, right? And then I can go in and fix it. Right? You notice that it gives you some stuff, right? In its value was what? 100. And the size of my string was what? 12. Right? Meaning the permissible values were only 0 through 11, right? It has to be less than size. So it's 0 through 11. Because computers always count at 1. So dot at gets you a character in the string. Dot at also changes a character in a string. Right? So if I want to say at 0, and I want to say equals the character j, you'll notice that I don't do double quote. Double quotes mean what? String. Single quotes mean characters, right? Dot at works with characters in the string. So we have to give it a character, right, in my string. So I'm saying s at 0, which was h, is now what? Right? It's a J, and now what do we have? We have Jello World. which is my favorite kind of world. Right? I should probably output it. See out S. And one. Build it. Clear it so you can see it. Right? We get Jello world. Right? Because Hello World's so old, right? Now we live in a Jello world. So .at allows us to get characters. It also allows us to change characters. Now we can take this idea of .at and use it, right, to do cool things, right? So we're going to join our for loop and our strings together. So I'm going to say int I equals 0, I less than s, and then I'm going to say dot length. Dot length is a function of strings that tell you how many characters are in my string. Right? I did dot length because I just taught it to you, but I like to use something called dot size. Dot length and dot size do the same thing, but dot length is 2 more characters, so you might as well just use dot size. Right? I starts at 0. I is less than the size of the string, and I is going to go up by how much each time? 1. Why did I start I at 0? Because strings start at 0, good, right? Strings start at 0, so I is going to start at 0. So I do things like cout, right? S dot at I. On your new line. What's this going to do? It's going to count to 11, right? And every time it's going to what? What's it going to output? I'm going to put the character to the string, right? So H, right? And then what's it output? A new line, which means that when it loops and I becomes 1, right? When it outputs E, where's E going to be? Right? It's going to stack. So we can run it, and they're nice and stacked, right? If we want to get super cool, we can do things like string. I think we do this way: new line character, and we want it to be I characters. I might have gotten that backwards. We'll see. We made it right. Oh, I did new line characters. I don't want new line characters. I want a space. Let's do better. I said be better. That's great.
What the heck happened?
Maybe I got these wrong. Maybe it's size and then the characters. That would make more sense. This is what happens when I try to do something cool, but I don't remember how to do it. There we go. Look at that. Isn't that so much cooler? Doesn't that look cool? Right? Because every time it loops, I'm putting a space for which iteration we're on. So first iteration, I had 0 spaces, then 1, then 2, then 3, then 4. So I get not only vertical, but I get horizontal and vertical, like diagonal. Okay. Because when you work on the console all the time, you've got to entertain yourself somehow.
Theoretically, you can make it like swing back and forth, right? If you wrote a loop and just had it keep doing that.
Mm-hmm. You can do all sorts of fun stuff. I'm just planting little ideas in your brain that maybe you'll want to do that sometime. What's the big takeaway? We can loop through strings. Okay. What's one thing I should have done with my loop? Anyone know? It has to do with the variable. What's the smallest that the size of a string can be? Huh? Empty, which its size is 0, and then to some maximum value, right? And so size as a function returns an integer, but it's actually a what? An unsigned int, because it can never be negative. Okay, which means that we should really make our int not be an int, but be a what? Gotta write that long word, unsigned int, right? Because I should never be -1 or -2 or -3, right? Because the smallest size would be 0. We're going to do that if you don't do that, you'll notice that on your labs you're going to get warnings. It's going to talk about a comparison between signed and unsigned integers. So that's going to be your warning. To get rid of the warning, unsigned it. All right, remember, in your labs and in your assignments, warnings are errors. Okay, meaning that you're going to get no points if you have warnings left over. Right? Warnings are warning you about something you did wrong that you should probably fix. Warnings usually are logic errors. So logic errors are the hardest ones to debug because they're logic errors, and so it's hard to find. So the compiler has warnings built in to help find, right, basically these logic errors that we. Questions there? All right. There's a bunch of other cool string functions that exist. They're in our lecture, but I don't think we really need them at this point. But you can do things like you can bind a string inside of another string. You can get a substring. So I want from character 3, right, to character 8. So from L to R, right? You can get a string from another string. That's a substring. You can find a character in a string. That one's actually pretty cool. So you can look for a character in a string. So those are in your slides. I don't think you're going to need them at this point in the semester. If we do something that you'll need them, I'll come back to them. But realize that because strings are more than just a plain old data type, they have a bunch of things you can do with them. Right? In fact, I did one. Right? If I go back here, right? Everyone see that? Right? This doesn't look like normal syntax, right? But strings are able to be built a lot of different ways. You can build them by doing nothing. You can build them by giving them a value. Here I'm building it by giving it a number and a character. And that will build a string with that many characters, right, based on the number. And so there's a lot of cool things you can do with strings, but we don't need too much of it at this point. Questions there? What we do need, though, are character functions. All right, so let's talk about some of our character functions, and then we'll be done with the lecture for today. So character functions allow us to check things on characters. String functions allow us to check things on strings. Character functions allow us to check things on characters. And we have a bunch of them. We have one called isAlpha. We have one called isDigit. We have one called isAlnum, right, which is a combination of alpha and digit. Right? These are functions, so they're going to have parens on them. All right, and they basically check to see if a character is one of these things. Is it alphabetical? Is it a digit? Right, that kind of stuff. So is alpha, right? If I said is alpha characters, somewhere with characters exclamation point. If I see out that, what do you think I'm going to get? Let's ask the question. Is alpha, right? Saying is alpha an exclamation point? Is an exclamation point an alphabetic character? No. So what do we think we're going to get? False, right? And for us, right, we think that we'll probably get 0. Right? So let's comment those out. And I get a 0. Are we good there? Now, if I did, right, G, what am I expecting? A 1. Okay, did I get a 1?
No.
What did I get?
Is that an ASCII?
1024. It's not ASCII, but the way these character functions work is they return a value that is not 0 if it's true. Okay? So, right, just to make things confusing, what does that mean for us? It means that when you write your if statement, you don't say if is alpha G equals to true. Okay, usually in algorithms 1, we really harp on the fact that like you need all you're going to just say equals true, equals false to really help with our logic. Okay, but what happens is that is alpha is 1024, true is true, it has to convert, and so it converts the true to a 1. Does 1024 equal 1? No. So that actually evaluates to false, even though we know is alpha is actually true. And so what we do is we treat it as if it was true, and we just get rid of the equals true. Because guess what? In an if statement, it's a Boolean expression. It will always become what? true or false. Okay? So if this becomes 1024, right? If 1024 is what? Is it true or is it false? True. It's true. And so the if statement runs. Right? So don't say equals true equals false. Just say if it is alphabetical, do that. Right? Is digits going to check to see if it's a digit? Alnum's going to check to see if it's a alphabetic or digit. And what do I mean by digit? What do you think I mean by digit? But not a number, because what am I working with? These are all what kind of functions? What do they work on? What's G?
It's a character, right?
It's a character because it's inside of what? Single quotes?
Mm-hmm.
All right, so digits are numbers that are characters. Okay? You only have 10 of them. They're on the top of your keyboard. Right? So, right? 6 inside of single quotes is what is considered a digit. Right? It's a character, right? So it's not an integer. Its value is not 6. It is the character 6. Right? And so is digit returns true if the character is a number, right? One of our numerical characters. Does that make sense a little bit? Right? We have things for like is punctuation, which is like commas and that kind of stuff. We have one for white space, like spaces, tabs, new line characters. Those ones you're not going to use that often. Right? But is alpha, is alnum, is digit, those are ones that are good. The last function that I want to deal with is one called toLower, right? And one called toUpper. Okay, toLower, right, takes a character and converts it to its lowercase equivalent. Okay? So if I toLower a character, if I do it in the right spot, a character, right, what is it going to become?
Lowercase a, right?
Lowercase a, good. Now, some things to know. If I lowercase a caret, right, it's still going to be a caret. You can't lowercase carets or tildes or exclamation points, right? The nice thing is you don't have to check. You don't have to be like, oh, it's not a alphabetical character, so I better write an if statement, right? If it is not that, then we'll lowercase it. It just won't lowercase it, right? It'll just keep it what it is. Okay. Now, one big thing for us to note, all right, let's output this. All right, we're going to see out toLower a. Okay. What did I get for output? Did I get lowercase a? No. What did I get? 97. Anyone know why? Output's garbage. Right? Something weird happened. Right. So C++ characters are based on the ASCII table. The ASCII table are basically numbers, right? I mean, bits that correspond to characters. So an uppercase A is 65. Everyone see that? And a lowercase a is what? 97. Okay. And in C++, you should get familiar and good with the fact that characters can be numbers and numbers can be characters. They convert back and forth between each other. Okay. And so what I got for output was 97, and that's just because character functions are super old. And so everything comes back as an int, not as a character. Okay. If I needed it to be a character, there's a couple things that we could do, like we could static cast it. So I static cast it to a character, toLower of a. Boy, that looks lovely. Right? Static cast to character, the thing inside the parentheses, which is the lowercase version of a. All right, and now I do not get, well, I don't get 97, I get what? I get 8. Most of the time it won't matter, because what you'll have is something like this, you'll have a char C, right? Get the input from the user, right? And then you just say C equals toLower C. If C was uppercase, it's going to lowercase it, but when it stores it back into C, C is a character, so it's going to not be a number, right? It has to be the character. And now I've just written a simple program to lowercase any input that I get. Alright, so what's waiting for input? If I do an uppercase H, it comes back lowercase h. If I do a lowercase h, it comes back lowercase h. If I do percent sign, it comes back as the percent sign. Remember, once again, if it can't lowercase it, then it just leaves it alone, which is kind of important for us. Right? That makes sense? Questions on character functions? All right, let's talk about why we might want to know about them. So let's look at our first coding assignment. It's due in a couple weeks, but I recommend start on it as soon as you can. Unless you're that student that doesn't want to do any of your work at the beginning of the semester, then you don't need to do it, right? Then work on it. So there are 6 functions that you're going to have to write based on kind of what we've been doing and review of what we did last semester. So let's look at function 1. Function 1 has a function named count characters. Okay. Notice it is count characters, capital C for count, capital C for characters. Okay. Just like in labs where I have a unit test that tests your code, bless you. This code assignment is also going to have a unit test that will test your code. But it's looking for a function called count characters to uppercase C's, right? So, and sometimes people miss the N, it's like C out character. Right? If you don't name it how I have it written, then it's not going to compile, your unit test won't work. Right? So make sure that if that's what I call it, that's what it is. The function, which we're going to talk about functions next week, I guess, because today's the only day this week. Function parameters, it takes in a string, and it takes in an integer, right? And what does it do? Well, it doesn't return anything, but it will count the number of alphabetic characters and the number of numeric characters in a string, right? So you get in a string, right, and you get in 2 integers, and you're going to set those integers to values based on how many things you count. Remember we did make change last week? Right? So it's kind of like make change where, right, a value comes in and then quarters, dimes, nickels, pennies come in and you need to set those to, right, what's inside them. How do we check if it's numeric or alphabetic? Well, we have a function called isAlpha. We just talked about that. And we have a function called isDigit, right? Yeah. So those will tell you if it's an alphabetic character or is a digit. And if it is, then you need to add something to account. Up and down is one of my favorite ones. All right. Up and down takes in a string, right? And it returns a string where the first letter is uppercase and the next letter is lowercase, and the next letter is uppercase and the next letter is lowercase and the next letter is uppercase, right? So no matter what string comes in, it'll just, right, vacillate between upper and lower, right? If it's, right, not able to be alphabetical or lower, that's fine, right? It'll stay how it is. We saw how those functions will continue to do that. How do I get to every character, right? Because this takes in a string, but in my example that I did with you guys, right, we weren't working with strings, we were working with characters, right? Ooh, I did iterate, right? Use an iterator, iterate, right, through the string, right? So we saw a for loop where I iterated through the string. You're going to do something like that. Count words. Function takes in a string of words delimited by a space character and count how many words there are. Okay, the key to this function, the string will never have multiple spaces between words or a space at the beginning or the end. So a clump of characters is a word and then a space, and then a clump of characters is a word, right? If that's all the words there is, there's only the one space in the middle. Okay?
Is there a space at the end?
No space at the end, no space at the beginning. Maybe. Something along those lines, right? You are not writing a dictionary. You do not need to check that clump of words and see if it's actually like an English word. Okay? I am saying that you will get words, right? So it's built in. You don't have to do error checking for that. You will get words separated by a what? A space. And then 4, 5, and 6 are a lot of fun. They all take in arrays, which we're going to talk about soon, right? Mean average will add all the values and give you the mean average in the array. Find min value will find the smallest value in the array, and find max value will find the largest value in the array. Okay, so those are the 6 functions. We're going to talk about the functions next week. We're going to talk about arrays next week, which will be everything that you need to do that. But if you want to start looking at this, start making some notes, right? Start typing it out a little bit. That will probably be useful too. I always write objectives. right? Because it's probably good for us to like have objectives of what we're trying to do. But really, what's the objective? Get better at coding, right? So that's the objective, right? Take what we've done in class and be better, right? That's the objective. I did give you files that are on CodeNV, assignment 1 CVP and assignment 1.h. And those files are the ones that you're going to want to write your code in. Make will compile using your own like test. Make unit test will compile using my unit test. Okay. And then you get points if you do your work, and you don't get points if you don't do your work. Pretty straightforward, I think. Questions there? All right, let's look at today's lab. All right, so we're in lab 3 today. I told you, I think we're doing Goldilocks today, right? So you're going to write a function called Goldilocks, a function called rock, paper, scissors, or rock, scissors, paper. Right? Here with ASCII value as string, and 2 lower and 2 upper. Right? Oh, and get character. I got lots of functions for you. Okay, once again, these things that are gray are called what?
Comments.
Comments. Who are they for?
Programmer?
The programmer, and they're for you because the comments tell you what you're supposed to do in that function. Okay, so Goldilocks tells the story of Goldilocks, right? So if an item, which is one of the parameters, is bed, right, and the number, which is the other parameter, is 1, then the story will say the bed is too soft, right? Notice item parameter will be passed in as all lowercase characters. C++ is case sensitive when it comes to like strings of characters, but I'm telling you that they will be in lowercase, so you don't have to make them lowercase. They will just work, right? So what happens if it's porridge and it's 1, then it says the porridge is too hot. If it's bed and it's 1, then it says the bed is too hard. Okay, where do bed, right, this item, this number come from? You'll notice that in the Goldilocks function, we have a string item and an int number. Okay, just to remind ourselves, because we haven't talked about functions yet, those things in the parentheses are parameters, okay? They are placeholders for values that come into your function. So you should not, in your function, like say item equals port, right? Don't assign it a value, right? Where does the value come from? Somewhere from the outside, right? In our labs, it always comes from the unit test. So I pass in porridge, right? Or I pass in 3, right? So remember, you don't need CN statements. Right? The values come in. If it's hard for you to write a function where you don't know what the values are, just think in your head, oh yeah, items porridge, items 1, right? How would I write the function to make sure that porridge in 1 gives me, right, the porridge is too cold, or the porridge is too hot. Does that make sense? Any questions on Goldilocks? All right, rock, paper, scissors, right? Character player 1 will be R, S, or P. Character player 2 will be R, S, and P, right? And then you have to decide if they won, right? If player 1 wins, you return a 1. If player 2 wins, you return a 2. And if it's a draw, you return a 3. Okay? One big thing about this one, lowercase or uppercase values are acceptable. So player 1 could be lowercase r, and player 2 could be uppercase s. And you return a what? A 1, because r beats s.
Why is it called rock, scissors, paper?
I don't know, probably just throwing us off a little bit.
I know. I used to do this to us.
Because it helps your brain think.
No, it doesn't.
Char with ASCII value as string, right? Return a string that contains a character and its ASCII integer value. For example, if the char passes an A, the function will return A65. Right? Because once again, characters and integers have this ASCII relationship between them. Okay. Now there's one big thing in here on line 99. It says hint, try a what? A string. Which have we talked about string strings? No. No, so we better talk about them, right? So string strings are a stream, S-T-R-E-A-M, right? Where else have we seen stream before?
In the woods.
In the woods, right? I know, I went backpacking this weekend, I saw a lot of streams. Right? Where else have we seen streams in code? IO stream, right? We include IO stream, right? And so we have this thing called CL, right? And cout, what's the beauty of cout? Well, I can output hello, right, which is a string. Everyone go with that? I can also output 5, which is a integer. I can output 5.5, which is a what? Float, right? So the nice thing about my cout string is that it seems to take in all types and outputs them, right? It doesn't matter if it's a string or integer or double or Boolean, right, or character, it outputs them. Everyone good with that? Where does this cout output to? The console, because it's cout, right? So console output. Everyone good with that? Now, this function says you have a character, but we need to return a string. Okay? So a lot of people try to do this. They'll say string s, right? And then they'll say s, and we're going to concatenate into it, right? Character. Right? And then concatenate that, right? Character converted to a number. We're just going to do that, character number. Okay, what's the problem? S's type is what?
String.
String. What's character's type?
Char.
Right, char. And what's character's type converted to a number? Int. Okay, the plus sign for concatenation does not work with ints or characters, right? It only works with what? Strings. So how do I make a string of a bunch of different types? Well, what's the hint?
String.
Try string, okay? And here's the cool thing about a string. Because it's a string, it works just like cout. Do we know how to use cout?
Mm-hmm.
Yes, so we should know how to use a string. The only difference, and we're going to learn how to do this. We're going to create a string called SS. Notice I did not change anything else. Right? And what this will do is instead of output into a console, because that's where cout takes us, SS will output to a string. What you can do with a string is that after you output, you can say ss.str, and it will take everything outputted to the string and convert it to a string, which is what you need to return. Right? So it's pretty cool and pretty versatile what you can do. We're going to use it a lot this semester because to build strings, which are very useful for me to test your code in, right? We're going to need strings. So the other thing that you have to do is you have to create the SS. So at the beginning of your function, you'll need to say string, and then SS. And then you can output anything you want to that string, and then you get it back as a string. Okay. Before you do this, you can just use cout, right? You can use cout and build what you're trying to get, and then try to implement the string to get it converted to a string. Does that make a little bit of sense? Yeah, hopefully it'll make more as you get into it. And then you're going to write a function to uppercase an entire string. You're going to write a function to lowercase an entire string, I think. Yeah, to lower, to upper. Right? So I taught you to lower and to upper character functions. Right? Can you write the functions to write uppercase and lowercase an entire string? Right? You're going to need some loops in that. And the last one is probably the easiest one. Right? Get character takes a string and the character index, and it returns the character at that index. Right? The hint there is to use a function called what? .at. Right? .at gets you a character at a given index. So there's not actually too much to that one. But read the comments because there's a couple things you have to do if it's like out of range. Right? Questions there? Nope. Okay. So lab 3 is for you to work on. Today, it's due tomorrow, right? We'll come back next week and work on functions and arrays and all that fun jazz. And your code assignment's due in 2 weeks.
For Goldilocks, we're just kind of writing, defining the cases.
Yep.
You're just gonna be, input whatever case you want through the function, and then we're supposed to output like for it.
Yeah. But you're not supposed to output it, right? You're going to return a string with what we're doing. So if what? If item doubles equals porridge and number equals 1, return the porridge is 200.
Oh,
And that's if you want to use and. You can also break it down, right? If item is porridge, and you can do subcases. right? You have options of how you want to build your cases.
So you're passing for each.
We just return the breakout of the statement.
What?
We just return the breakout of the statement.
Yeah, you don't have to do a return at the end. You don't have to build the string. You can just say return. Right? I'd probably do something like this, right? I would probably do if items reports. We'll do the last one. Bed, because I can see it. If item equals bed, right, and number equals 1, fine, then.
And define all the cases to
Case matters, so if you just want to copy what I tell you to return, right, you can copy it. So that's what it's asking you to do, right? But I think I give you 9 combinations, right? So you need to at least 9 cases.
Looks like we want to use a switch statement for that. Could we do on the case number equals 1?
So you could switch on number, but you can't switch on bed. So even if you do switches, you'll have to do ifs for the bed.
Gotcha. Okay, gotcha.
Yeah, so don't write a switch on item, because it won't work.
You do it with all if statement?
Yeah. If, else if, else if, else if, else if, else if, else if. And then I know some of you were having problems getting your labs up to GitHub. So just make sure before you leave today that I'll help you. Okay. Whatever you seem to have is But I haven't created anything yet because I was waiting for people to get all their stuff.
So if you use your, instead of pushing 3, we put 4.
And then just break out to that right now. So I'm gonna have to break
Yeah, that's what I thought, but on the notes, it shows something different.
No, because that's return.
It looks like it's on one also, but also here, it doesn't show.
Oh, you are confused. They didn't say you are.
You are.
No, it's good. Most likely. Return it, you don't have to. They work both ways. Yes, but it's sitting there for me like blinking.
Do you have a breakout here? There's statements.
No. I don't have a breakout.
shouldn't have done with the summer.
So it's like, I was put in probation, so
We'll leave it back.
So, when you call it, they tell you the complex, once you get the complex, you just get. We both got access to it. And then under additionally,
I would actually think it's what it's all separate files. Or is that have to make it another instance of 21 for the It's pretty simple. I just switch before it happens. Yeah, so put it all on. Or you can have, I was thinking about, I can make it easier. So like, oh, you want to play games, just don't change the
So, I was looking at the notes you have for and then when you say, so I don't need to like have to the whole thing.
Well, each case, each case, and so we need to like this out.
Okay.
And then, make things easy for you too. All of the, if you go to the class tables. What? You go to like.
No.
Then the notes on, canvas or business.
Yeah, so that, all the code that I do in here will always be, it's all built in.
Show me.
Okay. Yeah.
The first one I did.
Rejected.
What are they?
That's another job. I don't know.
No, just one.
Yeah, no, it's there now, yeah. Great. Send me the. Sometimes you have.
I only have one.
Statement, check the item first, and you will underline to the numbers.
Lots of different ways to attack it, yeah, that totally works. Everything to get up there. Not for two operands.
That's for that,
That
right?
don't matter.
It only takes in one character.
Alright.
That's like what it is. And then, if you don't, it doesn't automatically store it, so if you don't store it back into itself, it takes space.
That's just good in cases like this.
So you can't switch, did you switch on items? Or did you switch
Yeah.
on?
And then your else just.
Oh, yeah.
Because you know how you and that's the old doesn't always work. I'm gonna be completely typing this. The most deadly joke
I want to see this
I would go like,
I can't see those in the same series that I've seen, but I haven't watched all of them.
Yesterday I started watching the lots of this.
oh, yeah.
And so
I think parts of it.
I want to reference the most deadly joke of all time, at least once. It's my favorite joke. It's phenomenal.
I watched The Holy Grail recently and I was like, I don't know if I like this anymore.
My girlfriend watched it hated me because of it. I was like, oh, by the way, if you want to watch my favorite movie, like if you're multiple movie, watch The Holy Grail. And she's like, it's good. I was like, try it. Like,
Is it good? Yeah.
and then she's like, I hate you.
Maybe it's not good.
I hate the ending. No.
Seriously. No, you heard about it too all the time. Oh, it's just it's completely up in an hour.
You don't, so if you only have one, you don't know. All for the curly brackets, that way.
So I should,
Yeah, there you go.
this one, okay. And this one, I think this one, but,
The big thing to remember is that you don't need any, the character, player one and player two will already have balance.
Okay.
Which will be either R. So you can do like, if player one equals R and player two equals R. Like, how do you handle that?
oh, okay.
It's pretty similar to what you're about.
Okay, okay, and then, yeah, I can't tell if he's got my last, I don't know.
Okay. You can log in, you can log in. So click on yours. Yeah, these are 1, 2, 3, 4.
Okay.
So you rest of it.
But they keep not showing up. Every time I post flavor graph, I'm like, get up. It's like, they just get this else, right?
And then,
Because there's been somebody there, and no one's yeah, just put the else.
yeah, so here's the file that you created, not one, not two.
Yeah. Oh, I beat him. 15 years of service. We got like 13. We did this last semester.
Yeah, he showed us our student. What is this doing there? Look very.
Ask for.
Okay, so so you have the same thing, take it to the kids. I know.
So.
Really?
So this is.
You think I can get you a
Most likely.
needle that through? Probably not.
Sometimes.
Okay, I like that.
Yeah. The big thing was get like master now.
Okay,
We have that, we go up to the top, GitHub, I have the branch. Like 9 days from now, it's still CSCI, something, yeah. Right.
I love the us.
That's what, this is what I see. If I don't see what's in your code, then I see what's in there.
Okay.
I have that.
All right, thank you.
You're right. Saying that there's a way to go to the usually it's because your last one. Right, so what happens is if it's not, I never use but what'll happen is that, like basically, okay, so if item is 4, it's great, well, item is 2, it's great, right? Right, but if anything else, or it's not gonna do any of their distractions. Yeah, but since it's a string, right, you know, you would. It's fine, I don't tell you. But basically, it's saying, the compiler's smart, it's saying, I can get through your logic, right? Basically make everything false, and I won't know which one's good.
So, okay, yeah, it's trying to break it.
They're robust enough, they're really trying to help you out. They usually just use the one return outside of everything.
It'll say you have a
And just see if there's like you make it and just see if there's like error that pops up.
I don't see. Oh, yeah, it made it. I just did number 1. You want to see the volume.
That's when you type the query for it.
And then you explain it.
That's what it looks like after it's compiled.
Quote unquote, like it's right there. Like that paragraph, how you would explain to me. Period. I'm like, well, that's a thing. A second. No, that's. He put up the same like block of warning, so it's like, how do you try to do this? Like, because the thing is like, I've tried it, I'm feeling good about it, I've tried it, like, give it up, or I haven't tried it at all, just as notice. How many people put notes on? Yeah, well, because it's not a response. So she just got a response for it. So I guess look at the amount of people that have everyone. But I was like, oh, and it's a pretty, I think the default on the switch. Nobody's gonna reply to it.
I mean, you can right now, and just remove it when you're. Sure.
Yeah, that's like.
I mean, kind of the goal, right? I mean, I'm glad that you know that. The goal is to like do the logic yourself, so you just get used to what the algorithm's doing. You know what I mean? Like,
yeah. Because you already did the job. Right out. I want to move it. I don't want to hear it. I just do this for a while. Those comments over here at, my old.
I don't know, because sometimes you don't like that kind of syntax, or the way I write it.
What are these others?
But make sure you do the style check, let's fail the style check then.
Oh, is there a style check there?
Yeah.
How does that work?
You just type make space style. I know, it's a big one.
That means it's probably working.
Already working on it.
You think?
Shit. It's even more.
Especially if I don't stop him by the and he broke out.
Because I'm trying to think.
No, there's a problem.
Do a switch, right? Is that where you put
Wait, is that
player
a
one or player two? Or do you make another switch for player two?
I mean,
Okay, so
you know,
you're doing here, so you're doing case R or R, player one equals R.
oh, which one? Because which one?
Okay. Well, don't you need the single quotes?
So just returning.
Yeah, just to make sure that.
When you copy case for
I don't think we're on here, bro.
If you copy and paste errors, you just get more errors.
I did it before. I just did.
It's not a good idea.
Well, then what's wrong? Is there something wrong with the style or?
Well, we like to have white space, so that's, yeah.
Oh, okay. And enter on it? Yeah, you're choosing upper.
One case. Well, the keys are usually pretty good for the computer. Signature.
The only way to do based on that.
Well, that's really true. You know, if you look at their Twitter, they're saying they could release the PC 48 hours after the initial release. There was also some free one.
Yeah, you don't have to go.
No, not see the on the store. So that'll be the day one.
See two up with.
Well, like three. Then they have to go release three, and it's only the PC 48 hours after the initial release.
The same on that application, right?
That's why I don't work there.
What these are?
Yeah. So, and also, okay, watch 3 videos of your I'm not the
It's honestly built for like third graders. Pretty much.
I think everything's easier to consider.
Yeah. See, that's how it was first too. But then I just want the other people. Well, because you.
Keep generating randomly rock, paper, scissors.
Yeah, he's giving you, your parameters on the function.
Yes.
You see, you see everyone.
I don't really understand switches that well. Because I was gonna use MIP, or MIP.
Yeah.
But, so, okay, so in the word switches,
My worry is that you're just taking what it's not. If you were getting and it's part of the agreement. You're just finding the result.
I thought you would need like a CN or something to get
Yeah,
there.
but.
you also have to have
You're
a
just
check.
taking what you said, the last one.
No, don't you have, aren't you supposed to have a check to see if that really looks right?
Well, I'm just taking the player's choice right now.
Okay. Okay, so you haven't gotten to the Booleans yet? You haven't gotten to like the, where you can check to see if it's R or S, then,
For that, would you have to switch that to where it's using it?
I think the entire function requires a switch. If it says it requires, yeah, so you must use a switch.
So would you just create a third switch for that?
I'm thinking, I don't think you have to write this much code. I'm wondering if in the switch area
So
is where you
you
actually
create
check,
string
or
SS,
if you have to.
then you'll SS output like C out to it, and then you'll return SS.str at the end.
So you would say, well, player one is on, that's player two. And then like the enter keys. And then you plug
It says care player one.
STR.
Okay, so that already got a variable, so you say,
So, and then it's technology.
no, it's not gonna work.
So that's the setup. Okay. So you're gonna create a string, and at the end you're gonna return its string equivalent, and then in here you'll SS, and then you'll output whatever you output to it will show up in the string. So you need to output the character a space, and then include the ASCII.
So I'll put the character, right, how do I get this value then?
Well,
I forget.
well, this is it as a character, and that's it as an integer. So you need to stack cast it.
Oh, okay.
Yeah. No, it's good. Don't recreate the character you already have.
Oh.
Oh my god. I didn't think
So
that.
right now, what you would have.
Oh, no, no. Either one. Well, like, it works the same way.
So you need to get a space. Once again, imagine this is a cout, so just imagine that you operate.
For the case, couldn't you put or? So you could say case uppercase R or lowercase r, just to save space.
I don't think you can use those operators.
You can put that in the switch up here, right? Like you can say player one or player two. Hold on.
Because that's already a string, I can't just word it in the editor. Yeah, there's no X in that's my red.
Oh, okay. Okay.
Your goal is to convert the character.
It doesn't seem
I guess like humans are all right. It's just
what are you trying to survive? That's why I was highly like looking at.
Yeah, give me an email if you want it.
I'm thinking of the input right here. Maybe like something like this.
You can't switch on two things. You don't switch.
Hey, you want to do a switch?
And player one would just speak to an R and S. So variable player one, player two is just a random S or not.
You can do whatever you want. But I want it to conform.
Yeah. So rock, scissors, pick first. The key is on line 1 to 7, you have two variables, player 1 and player 2.
Yeah.
So they're gonna have values, right? And so your goal is to compare those values and figure out who won.
Alright, I got that, but I'm assuming we're gonna be using like this.
Well, that's the function. So you already have that.
So we're not gonna be.
So you're gonna switch on either player 1 or player 2.
Because I know the first thing is, using the equality and
So you're gonna switch on like player 1 and then work out their cases, like case R, case S, case B.
Okay.
No, so yes, actually.
No problem.
Yeah, that's true. Why is it anymore?
I'm passing around a sign sheet, so just make sure that you sign it before you leave today.
Did you figure out anything?
Yeah, I decided, like, it's gonna be a long one, so we gotta start with like player one, right? And I would say if he types the letter R, his character is set to R. If he types lowercase r, it's R, and then I have to write all of that. And then I gotta do it for player two. And once I do that, then I have to compare the stuff. So I say switch play, right? Switch play, and then I'll say case R and S. Then Rock wins. And it'll return for that player who won.
It's just nice to like group them together.
You see what I'm saying? Like I'll get to that point where it'll say, I'm gonna do switch for player one and two, and then once I'm done with that, I'll do switch play, and then it'll check R and S is Rock wins, and if whoever chose R, that person, it'll say the player one or two wins. It'll return a number because it says you have to return an in out of this function. So I'll try that.
We holding on to the line on two folks at the same time.
Could be. Maybe she's eating her porridge on top of the bed.
Yeah, right.
Which has the chair on top of it. No wonder she's not happy.
Because that means that it's not negative. That means it's just
I try to give you a little structure on your switch too if you're having trouble with that.
Wait, so you have to do a switch for upper and lowercase for both players? So you have to have 4 switches?
Does that make sense?
Is that necessary?
What's the enum stand for?
What did I say you know? No.
You don't, but in the previous switch you did.
So enum is just enum helps like, okay, if this was really case 1, 2, and 3, 1, 2, and 3 don't really mean anything to me. So enum allows me to name it. So it allows me to name it RS or P or something. Something that makes more sense in my way.
Wouldn't this require 4 switches? Because you have to do 2 upper and then 2 lower if they type an uppercase letter.
Correct. But I uppercased it right in the controlling expression, so it will always be uppercase. You have to stab your cases, it can be case.
Oh, so if they type uppercase R or lowercase r, it's still going to be upper regardless.
Which is why I did.
Oh, so that saves a lot of space.
And I said you only do one switch, so if you want to do ifs inside of those cases, you can. You don't have to do switches inside of the switches. Start looking at it. Yes.
Okay. Just double check that. And then string dot length or string dot size.
Tells you how many cases.
You ready to break?
You need to bring it to the end of the case.
We put a return statement.
So you don't need to. Return one of your function.
You want me to?
I mean, it's for the same thing as an else if.
Oh.
And then the only other thing is that it's more efficient.
Because it's like you have to do that switch. You can still take some of this logic and put it inside of the structure. Yeah. Yeah, although that numeration won't work. Numeration only works for the strings. You have to do this. You switch on the items and you like hit on the you switch on the number and then hit on.
No, you.
We don't have to do much with them, so that's good. This is the only time we're gonna force you to use those.
Oh, you have to make another switch for player 2, huh? Yeah, you gotta make one for player 2.
That's probably because it's the function one to the function. Probably fine.
Zero.
So now, like actually this one.
Sarcastic bigger than oh yeah, you can't have like if I put it on high, I can't ask it to read. It doesn't make sense.
That's I should make it all the way around. Oh, there we go. That's somewhere.
I didn't get it either. Oh.
Oh, yeah, that's what we do.
Like pseudo subscale. Develop your logic first. That's why I like that. Oh, wait. Other than that,
That's what you mean.
John?
So in a switch, I think you're supposed to do like the comparisons, have one like after the case. So you'll say it'll say like player 2 case R. You have to compare his R in all the different types, right? And, I mean, it'll automatically uppercase it, right? So you don't have to check lower and uppercase. And what you'll do in that,
Two ways are.
like right here, after this case, for example, that's player two's turn, right? So it's already P, right? So that you don't need this because somebody already inputted this somewhere, and you would do like a check to say P and like P and S would win. So you would return player one wins. But I'm not sure where you would compare this.
So what else helps you?
I don't know what you. That's what I'm confused about.
Oh, no.
I don't know what to compare. Because after the case, then you're supposed to compare it. And then what it'll do is it'll return like an integer, say that first number is a draw or whatever. So I think I only need two. Because there is another string called play somewhere. Because if you look at the instructions, it says it's a play somewhere.
Two lower jar has. Sometimes the hardest, but yeah. It aborted right away.
So, this is basically saying if, whereas two numerals is saying if player one equals R, if player one equals X. If player one well, the hard thing is now, so you stop like. Let's bring it down, okay, player one is R after.
Okay, and then I have to return Y, and then does this make it matter when it's lowercase or not?
It does, so what I did on mine, let's say.
Oh, you can put if statements inside the case.
So we're gonna switch on uppercase.
So you can put ifs inside the case saying if R and S, then it'll say, or whoever had the R would win because rock beats scissors. So you can put an if statement inside the case, but then you would have to figure out how to know who put in what value. So you would say, hold on.
You don't have to. Because that's the end of the switch.
Struggling with the rock, paper, scissors thing?
Yeah. Because inside a case, you have to somehow compare the two players' moves, and then you would say if it's a draw, you return 3. If it's a player 1 win, you return 1.
Oh, so you're supposed to return
Yeah.
1 and 2?
Yeah. Did you do this already?
No, I was working on the switch statement for player 2, but I wasn't sure what we were supposed to do because
I'm wondering
I just did if I did case R in single quotes and then put C out lowercase r. This was given to us in uppercase, but wasn't sure what we're supposed to do with ours.
I think inside the case you have to compare the two players' moves. So you say if.
Yeah, you only have to write a switch statement. You wrote it.
I don't know how to do that though, because I don't know how to get that
And
information.
player 1 equals R, and if player 2.
Well, that's already saying it right here. If case R, so player 1's move is R. Then you have to say when he has the move R, then what happens? Would it compare? It would compare the player 2's move, right? And I already have a switch case for player 2, but then I don't know what to do after the case.
If player 2 equals R,
Yeah.
it would be.
Yeah, you're right. So I would say if. Yeah.
Thank you, by the way, because
Yeah.
I'm stumped on this.
Yeah, what you just said makes more sense because I can say if player 2 equals R, then this is a draw. And else if player 2 equals S, player 1 wins.
Thank you. I was just staring at the screen, just so confused.
Yeah.
that makes more sense. I don't know how to do my thing.
I thought you did.
No.
You're right there.
No. How do I fix this?
Oh, hit insert. Insert. Is that it? Oh, okay. It's all Pac-Man.
Luke, do you make inputs for player 1 and
Reading everything.
do you make inputs for player 1 and 2 in the test, or just player 1?
I pass in values for both.
Okay, so I can make a switch case for both, because I'm going to be checking player 1 and player 2's.
Yeah, but you're gonna check them against each other.
Yeah, that's what I'm going to do. I have a switch for this, and then I'm going to be comparing it.
Okay. So you're gonna switch on player 1. Okay, so this put in quotes. Then this character will match this character. Yeah, exactly. And so inside of there, this is where you would do your matching. So here, where you would say something like, I like anything here. If player 2 is also on. And so you just wrap all your others. Yeah, you just have to make sure, because otherwise it's going to think that these are variables. Same quotes make it.
Yeah, so what's it? No, because I got it. Didn't it start like way after you go? I didn't do any homework over the weekend.
You should be able to.
Feel better than a month. That will tell you.
You should be able to, get
Do a little follow-up. Right here.
Hey, John, come over here real quick. So this is what I did. And underneath the case, right, I said if player 2's move is R, return 3, because it's a draw. Because R and R is rock and rock. And then else if player 2's move is S, which is scissors, return 1, because rock beats scissors. You see, and then I have to do that every case, which is kind of annoying, but can't really do anything about it.
See, I didn't even return it to the console. Return means I can do something.
Yeah.
The sign sheet make it all the way around?
Yeah, I got it right here.
What happened? So what's going on with that? Feels like we've got all the. That's it really bothers you? Just return the end. That one, yeah. Or string dot slash one. Make sure there's friends on the end.
I'm just going to test this
Okay.
to make sure it's working.
Okay. So,
So basically, I see myself with a little bit like this.
Yeah, I want to get an iPad so I can have it longer.
Yeah.
Cool.
And then I type search.
Who's like, how do you know like?
No, it's, yeah. That's nice.
I mean, the fact, yeah, I don't.
Yeah. I mean, obviously, I use my calculator. Right?
No, Andrew, they true. What? We kept 120
Alright, time to test.
Well, it said it's wrong.
There's an error somewhere. No, okay, that's okay.
Well, for the default.
Yeah. I'm sitting 4 hours. After close my work.
To upper was not declared. I see. Let me fix that.
So, you know, you were like going back and forth, going.
If it's greater than or equal to 0, then
I have made no progress. I think I messed up.
Yeah, I did that, but it's not working. It's telling me that it's trying to compare lowercase r and uppercase s. It's not working. Which doesn't make any sense because it told us we were just making uppercase r. I'm gonna write the rest of it and then I'm gonna ask you.
Basically, convert to an integer that equals make it.
Yeah, I'm kind of, my class.
Do you need to convert it?
Everything works.
I just don't know how to get it back then.
I did a help there. Your first question?
Few times where I can actually, any trips where I can write back.
This just go plus. Okay. Because it's brown.
So is there a way to like copy and paste? I find that. Oh, now.
That's a lot of errors. Kind of set it up, to be honest. My guess is that maybe it's
stresses that it's trying to, it's not using it. So, I think the big thing here is that if you can say string porridge, that's gonna make porridge. Right? So you can create strings, but really you just need to.
Yeah, I'm not gonna do that.
Yeah, that's the same thing with Yeah.
Yeah, I know, he showed me that video. That shit.
Yeah, anybody.
I did get really cold. I mean, that hurts so bad. Not more bad. Just didn't fucking find it.
Are you getting errors for the letters not being declared in the scope for your switch case?
Here's the non-GD.
Oh, you don't have single quotes.
You know it's true.
So your only problem is
What's that? That makes sense.
Always have to declare in the scope.
You notice that.
If your string is like here,
If player 2 equals R, return.
Oh,
that's why you're getting out.
oh my God, we're so advanced.
Else if
Which is why we use that add because it crashes when it crashes and lets us know.
Yeah. I just right clicked on the window.
If you scroll down a bit, is there any other instance where you have single quotes?
Static cast there. Static cast to an
Interesting.
If you go to, you're gonna have to look at that. If you go to the sample code.
It's weird. It's like you were ready for this one.
Seeing the
Okay.
That's why. So I just threw it. That's why one of the problems in my confidence. This game is pretty good. 8.3 is pretty good. 6.2 was
Luke, I have a tiny problem.
Okay.
You know how you suggested to make all the inputs uppercase?
Yeah.
Yeah, it's telling me it's trying to compare lowercase letters and it's not passing that test.
Well, I'm giving you lowercase letters, and hopefully your code's fixing that. Let's see where.
Okay, let's start at the player 1 here. So
you switch on to upper, good, but the problem is player 2 could still be lowercase.
try to say or here.
But you can't do it. Yeah, you could do ors. The easiest way though would be at the very top. Just say player 2 equals, right, 2 upper.
Okay.
Right, player 2, basically the same thing that you did there. And so then it's just converted at the very beginning, and then you don't have to worry about it. 2 upper paren, you just have to put player 2 in the parens, yeah.
Yep.
But now player 2 is always uppercase as well.
One time, my friend Epic Game one. No.
Yeah.
All right. It was almost long. They won't all be this long.
I think that's Numeration. And I put in the router. And it says, would you like to use the old information? Yes. Everything done. And I walked away.
I didn't realize it was the card to get another one. The bank will give your credit card, your new credit card. So they don't see you know that? Yeah, like iTunes, they keep getting my fucking credit card, even though I don't have an iPhone anymore.
I really put it hard, but I can call it fraud.
Let's try that.
Oh.
Not good.
Yeah, you should move it. Oh, so you'll go. You have CD labs, CD lab 3. So you CD lab. Labs.
Did you pass all your switch tests?
No.
I failed the 7th one, but
You passed the other two?
yeah, I passed all of them except the 7th.
How'd that happen? Because I'm failing every single one of them.
Necessary test hard.
No, I didn't do that. That's my
And that'll change all of it to uppercase letters.
Yeah, and then that's loaded in one white.
So you made lower.
Well, deleted if you fail all these tests. These are warnings. So, and now you passed one.
Still not
So I didn't pass anyway. So I don't know what the problem is. I need to come over there.
Do you wanna start like a Discord so we can talk about this stuff or something? If you got time outside class.
Yeah. Yeah, we can do that. I can just text you. So let me go through your code real quick. So at the top it says player_2 to upper player 2. Okay, switch to upper player 1. Case if it's R, player 2 equals R, return 3. Okay. Else if player 2 equals S, return 1. Player 2 equals P, return 2. Break. I did case S, but oh, I think I see the problem. No, that's not the problem. So case P you did, right? So I say if player 2 equals R, return 1. If player 2 equals S, return 2.
Yep.
If player 2 equals P, return 3. Break. For case S, it's if player 2 equals R, return 2.
Yep.
If player 2 equals S, return 3.
Yep.
If player 2 equals P, return 1. And then did you make a switch for player 2?
No.
No?
It's just player 1, then it compares it within player 1.
I'm gonna comment this out and see what happens.
You can see on this because Visual Studio did 2 spaces go on top of this. You want me to go through and add 2 spaces?
Yeah.
There's a program called tabs to spaces that will fix it for you.
Is there?
Okay, I commented it out. I want to see what happens. I got warnings for other reasons, and I still failed. I think I might have accidentally commented too much.
It's crashing because you're returning 0. With the function of you're returning.
So you didn't make a switch for player 2, right?
No, I originally did, but I just deleted player 2.
Because then you're returning a string, not I think.
Okay.
That makes sense?
Yeah, the string would be 0.
Yeah, right,
Let me
exactly.
see where this
Double
starts.
quotes is 0 for strings.
Oh.
Right.
Where does that bracket start?
So, given this input, I want to start at 0.
Okay, let me see where that starts. Okay, it starts on the switch. That's the closing of the switch. The closing of this switch
You know which index I want.
is that right there.
So that tells you where a character is located on the screen.
Let me just remove this entire switch.
Find it. You can just say, I want the character at location 0. Little at
So I
location.
just put input.
There, I just commented out that entire switch.
So the function, it's a member function called .at.
Okay.
Right, so whatever the name of your string is, string.at, and there's some number in there.
Oh, so
That happens to be-
I got a bunch of errors on 2 lower. Oh. Oh. Okay.
It's like 2 lines.
That's for some other function,
No, the
but
only thing is I tell you that you have to check for that. So you need this statement, right? If chart index
yeah, let me see.
it has to be what, greater than or equal to 0 and less than. Then you would get
I still got a bunch of errors.
Otherwise you return.
Still failing those tests. Okay, I'm gonna have to work on that.
Is there a way to log out of this or do you?
Zero for character, basically.
I think 84 and 1.
Go back and look at this.
Semicolon, but I don't know. Before this. Get all steps. Oh, yeah. I think we can. Okay, cool.
I think it's something way worse. When you did that, it was going down.
Except for there for some reason.
And then you copy and paste it into the propagated.
If statement checks bounds,
Yeah, right?
whatever you input that length.
If it's greater than that and less than, right? Right, is at least 0.
I guess I can get rid of one.
And it's less than how many B, right? And when right there, one side. 0 for characters backslash. So I didn't talk about this in class today, but I'm gonna start talking about this. Returns in a function, right? So I don't have to say else return. Like, could this happen? And the function only because of return. So to get here, that is my else. So I don't have to wrap it.
The other thing I was kind of weird, 16 and 17 without writing anything.
Yeah, it just could be, you just find out like. Do a style, maybe. Make style.